This video is going to show us how we can find the area of a region that's bounded by several different equations. And if we look at the three equations we're given here, we have y equals x cubed plus x equals 2, and y equals 0. And you can see over here I've already got the graph of x cubed plus x. We have y equals x cubed plus x. And the graph of x equals 2, if we go over to 2 here, that would be this line here, x equals 2. And of course, y equals 0 would certainly just be the x-axis. So what region is bounded by those three graphs? We have y equals 0, x equals 2, and x cubed plus x. And clearly you can see we're looking at trying to find the area of this particular region here that is bounded by all three of the graphs. So we are going from, on the x-axis, from 0 out to 2. So there's our limits. So it looks like we could then integrate to find the area would be the integral of 0 to 2. And the function we're looking at is x cubed plus x. So there's our function. So if we simply integrate now, we would have x cubed becomes x to the 4th over 4, plus x becomes x squared over 2, and then we have to plug in our limits from 0 to 2. And once we plug those in, we're going to end up with 2 to the 4th over 4 plus 2 squared over 2. So we're going to have 4 plus 2 squared over 2 is 2. And then it's going to be minus the lower limit, so that's 0 plus 0. So we just have 0 plus 0. That's going to all cancel out. So therefore, we end up with an answer of 6. So that gives us the area bounded by these three functions. So this area would then be equal to 6. All right, here we have another example. We have two equations, y equals 2 squared of x minus x, and y equals 0. The graph of 2 squared of x is given for us here. And once again, y equals 0 is going to certainly just be the x-axis. And again, the region we're going to be looking for the area for is right in here, because this is what is bounded between these two graphs. And it looks like we're going to start here at the origin at 0. And the question is, where does this intersect, or where does this stop? That's what we need to identify. Well, we can find this point by taking our equation, the graph of this equation here, and we know the y value is 0. So if we take 2 squared of x minus x and we set that equal to 0, we would have 2 squared of x equals positive x. And then if we square both sides, don't forget to square the 2 out front, so that's a 4. And if we square the square root, that becomes x equals x squared. And if we move everything to one side, we would have x squared, move the 4x over, so that's a minus 4x equals 0. And if we factor out an x, we have x minus 4 equals 0. So we know that x is equal to 0 and x is equal to 4. And we can tell we were right for the initial guess as 0. And over here where it crosses the x-axis is certainly going to be at 4. So if we set up our integral to find the area of this region, we're going to be integrating from 0 to 4. And our function that we have is 2 squared of x minus x. And I'm going to rewrite that as 2 times x to the 1/2 minus x dx. And if we integrate this now, 2x to the 1/2, that becomes 2x to the 1/2 plus 1 would be 3/2. And again, instead of dividing by 3/2, I'm going to take and multiply out front by the reciprocal, which is 2/3. minus x squared and divided by 2. And then we have to evaluate this from 0 to 4. And before I plug in to evaluate, I'm going to simplify inside a little bit. We have 2/3 times 2, so we could certainly simplify that to 4/3 x to the 3/2 minus, and we could think of this as 1/2 x squared if you prefer. And now we can plug in our limits. And remember, we want to start with the upper limit 4. And if we plug 4 into x to the 3/2 and multiply that by 4/3, we're going to end up with 32 over 3, because you're going to have the square root of 4, which is 2. 2 cubed is 8. 8 times 4 is 32 over 3, minus 4 squared, which is 16, and then half of that would be equal to 8. And then remember, it's minus the lower limit, so if we plug in the lower limit, once again, both of those are going to turn out to be 0. So we have 32/3 minus 8, which is equal to 8/3. So that will give us the area of this region that is below our function here and the line y equals 0, which is the x-axis. So here you have two more examples of how we can calculate the area of a region that is bounded by several different graphs. Just make sure you look at the region that's bounded by all the graphs that are listed, and then you can indicate the limit that you're going to integrate from 0 to 2, and just integrate the function that's listed.